Okay, this time we are going to practice a very famous limit that looks like limit x approaches to 0 sine alpha over alpha is equal 1. Okay, sometimes this formula can looks like limit x approaches to 0 alpha over sine alpha, it's still equal 1. If you don't believe me, try to prove it. It's very easy. It's not difficult at all. Okay, now here's the thing. We don't necessarily have to have only one variable or one parameter alpha. It can be, let's say, we can have the argument parameter can be more complicated, like let's say limit x approaches to infinity, approaches to 0, sine 3x over 3x, it's still equal 1. Or limit x approaches to 0, 5 over 2x over 5 over 2x. It's still going to be equal 1. So this parameter can be complicated also. Let's say if we have another example, limit x approaches to 0 and you have sine arctangent x over arctangent x. Cotangent is not going to happen, only arctangent, because our tangent is the same sine over cosine, right? Okay. And also equal 1. Even more complicated case we can have limit x approaches to infinity, 0. I keep saying infinity, it's already becoming habit. So we have, if we have x cubed minus 5x squared plus x over sine x cubed minus 5x squared plus x is also equal 1. See the whole argument or parameter. See, it's like alpha over sine alpha. Yes? But look here, I'll show you interesting case. If you have limit x approaches to 0, and if you have sine x squared minus 3x plus 5 over x squared minus 3x plus 5 equal 1, it will be absolutely wrong, because the limit when x approaches to 0, it's going to be equal 5, right? So in these cases, if you have polynomial under as in a parameter of sine, you cannot have available term, because if the x is equal 0, the limit will have that available term. In this case, it's going to be equal 5. Pay attention here, we don't have available term, we have x. So which give us 0, limit gives us 0 over 0, and after doing some simplification and changes, we are getting 1. Okay, it's very important to pay attention on such things. Now, let's solve example after I wrote down all these cases. So let me solve example. Let's say limit x approaches to 0 sine 7x over 3x. So I can't have it, I have to have 7x right in denominator. Therefore what am I going to do? I'm going to, I need 7 here, right? So, and then multiply 7 also here. And from there, I'm getting limit x approaches to 0. 7 I leave out. These 3 also get out. And I'm getting sine 7x. And leave here 7x. And the answer is going to be 7 over 3. Because this one, we know it's equal 1. So the bottom line is, if I have limit x approaches to 0, sine, let's say 5x over 2x, the answer is going to be 5 over 2. If I have limit x approaches to 0, 9x sine 9x over 5x, the answer is going to be 9 over 5. Okay, we good? Next, what else interesting thing we can find? Let me see. Yeah, I can do such case. This is also interesting. Limit x approaches to 0. We have sine x, sine 5x over sine 3x. So I'm going to convert into a formula we know, sine x over x. So with x approaches to 0, obviously. Okay, this is what we are going to do. Limit x approaches to 0. I'm going to, I am going to represent in the form of 2 fractions. Sine x will be, sine 3x will be here. Sine 5x will be here. Now this one, I need sine 5x. I'm missing 5x, correct? So at the bottom, I put 5x. On the top also, I multiply by 5x. Here I have sine 3x. So I'm multiplying here 3x. And here also multiplying 3x. And what do we get? We are getting, this is equal 1, right? And the equal 1, this is equal 1. And we are getting limit x approaches to 0. We get 5x over 3x. X's we are canceling. And the result is 5 over 3. So again, look here. Oh, okay, let me change the color so we can see. We are still getting 5 over 3. All right? So if I have limit x approaches to 0, sine, let's say 11x over sine 7x. It's going to be equal 11 over 7. I have limit x approaches to 0, sine 15x over sine, let's say 7. No, 7 we used already. Let me use number, it's not divisible by, okay, 8x. So it's going to be 15 over 8. Okay? All right. Next, let me see. There was a problem I was interested to solve it. I saw it. Yes. Let's solve this one. I had marked down, so make sure I will cover this one. So limit x approaches to 0. And we have sine square x over x. So I'm going to represent as a limit x approaches to 0. We put in parentheses. It's going to get what? Sine x here, 2 fractions, and sine x here. So Sine x, here I divide by x and multiply by x, right? So this is going to be equal 1, and I have here x, okay? And what we are going to get, sine x is going to be equal 1, right? And x is 0, so I will get limit x approaches to 0, x times sine x. Look, I could convert this sine x also into same changes, x here and then another x here. But I'm not doing y because I end up with x here anyway, right? Which is going to be 0. Okay? And this is going to be our answer. Okay. Another one. Let's solve another one. I have number 4. I have limit x approaches to 0, and I have 5x squared over sine squared x over 2. Yes? What is going to happen? This time we have opposite. Sine squared and 5x squared we have. So if we plug x's 0 into x's, we get 0 over 0, right? So we're going to now do some changes. 5x and then time x, right? Here I have sine x and half, sine x and half. Okay. Limit x approaches to 0. Okay, now here, limit x approaches to 0. So what am I missing here? 5. Since I have sine x over 2 and I have here x, right? I am dividing by 2 here and multiplying by 2, right? So this piece, I will have 1. But I have another sine x, half of x, right? And here I have another x, correct? So let me see. Let me change the color here. Divide by 2, multiply by 2. Same thing I'm doing here. Divide by 2 and multiply by 2. Which means this piece also will become 1. And as a result, the answer is going to be 5 times 2 times 2. And that is equal 20. Okay, let's solve one more. So limit x approaches to 0 and we get tangent 2x over 2x squared. Okay, so again, we get 0 over 0, right? So we're going to do changes. Limit x approaches to 0. We are getting 2x squared stays here. Tangent 2x, I'm breaking down sine 2x over cosine 2x, right? Now, cosine 2x, it's 1, because cosine x is 1, right? So cosine 0 is 1, and x is approaching to 0. So we have sine 2x over 2x squared. Right? So let me see, limit, oops, okay, limit x approaches to 0. So from here we are getting limit x approaches to 0, sine 2x over 2x and times separately x. So this piece is going to be equal 1, as we already know, right? And we practically are going to have limit x approaches to 0, 1 over x, which is going to be 1 over 0, then this is equal infinity. So this also, such things also can happen. All right. Okay, let's solve the last one, and that is the advanced one. So I would highly recommend trying to solve on your own first. See if you can handle it. If not, then come back and see how I solve it here. So cotangent x times 1 minus cosine squared 3x over x squared plus 5x. Okay, I don't need parentheses here. I don't know why they put parentheses in the denominator. There is nothing else. X squared plus 5x, so we absolutely don't need parentheses. All right, so let's start solving. Limit x approaches to 0. We have cotangent x, I'm going to break down into cosine x over sine x. Yes? 1 minus cosine squared 3x. Might as well write down 1 minus cosine squared 3x, write down as sine squared 3x, right? It's from cosine squared plus sine squared is equal 1. That's we got from there. Sine square x plus cosine square x is equal 1. Okay, let me use bright red color because this is a formula. Okay, we're good. So cosine over sine and then times 1 minus cosine squared 3x is sine squared 3x. Yes. And x squared plus 5x, I'm taking common factor out and getting x plus 5. Yes. So what's happening in this parenthesis when x is approaches to 0, this was gonna be 0, right? And this 5 is gonna survive, so 1/5 is gonna come out because we don't need this 5 anymore. It doesn't have 5, it's doesn't have x, it's a constant. And here we have limit x approaches to 0. Sine squared x. What else we have here interesting? I forgot to also take care of that one. Cosine x, so cosine, if I plug 0, cosine 0 is going to be equal 1. So let me rewrite clean. We have left sine squared 3x, right, over x times sine x. Okay, now you could say why I didn't plug as a 0 of this one also. I did not, because if I would plug 0, this is multiplication, the whole denominator would become 0. That's why. But this x, when approaches to 0, it doesn't affect the entire denominator because it's tied up with addition. So we are good at this point. All right, so what I'm going to do now, this one, I'm going to write down 1/5 comes out, limit x approaches to 0, breaking down sine squared. sine 3x, sine 3x. Yes? Now, since I have here sine 3x, I will need, let me move this a little bit further, and it doesn't matter that I put the two fractions, it's not going to affect anyhow. It's perfectly fine. So since I need 3x in denominator, right, to get it equal 1, so I multiply here also 3x. Let me put this way. In this case, here I put in parentheses, so we would know it's not sine 3x times 3x. It's just sine 3x multiplied by separate 3x. Yes? So, and here we still have, let me see. I didn't put here sine x. We have here sine x also, yes? This one. And here I put x, this x, right? So here I'm going to multiply and divide only by 3 because I have x already, so this is going to be also 1. This is going to be also 1. And for sine x, I need to multiply and divide by x, right? So x over sine x, it's equal 1. So this is equal 1, this is equal 1, and this is equal 1. So let's rewrite clean what we have left. 1/5, limit x approaches to 0. We have 3x, this one survives, this one survives, and this survives, yes? So it's going to be 3x times 3 and divided by x. Yes? So this x we cancel with this x, and the limit has nothing to do with this 9, 3 times 3, but therefore, because it's a constant, so it's come out 9/5. And this is the answer. Okie dokie. Thank you for watching. And I will continue. Next time we will talk and work with definition of E, which is practically, let me write down, it's a limit x approaches to infinity, 1 plus 1 over x to power x, and that is equal E. This is what we're gonna work with. Yes, and very important thing, I forgot to talk about all these problems we solved. When do we use it? First of all, we use when we have kind of sine x over x, right? And for the second, it's also very important. Every time when you plug into problem, you have to get first 0/0, and then you start working this out. If you check everywhere, look, let's say, let me come here, 7x over x, sine 7x, it's going to be 0, right? Because x is 0, sine 0 is 0, right? 0 divided by 3x. If you plug 0 instead of x, you get 0/0. Second one, sine 5x over sine 3x. Again, if I plug zeros, then sine 0 over sine 0, it's going to be 0/0. Here, sine square x over x, also for math, 0/0. Everywhere you see, we are getting 0/0. That's only in these cases we can work out and apply this formula. All right, and next time I'm going to talk about this formula and practice problems that involve this case. All right, See you next time.